first thing we're going to do here is, for number 76, is we're going to type in the function. Again, negative symbol underneath the 3 and 0.002. And then instead of using t, we don't have a t in our calculator in function mode, so we're going to use x to represent t in the problem, raised to the 4th power, and then plus 0.039 multiplied by x raised to the 3rd power, minus 0.285 x squared plus 0.766 x plus 0.085. So there's our function, and it represents the concentration of a medication in the bloodstream t hours after being administered. And so the question is about, after how many hours will the concentration be the highest? Well, we got to figure out here what would our window be, and t represents hours, and so the lowest number of hours you could have would be 0. And let's go ahead and just estimate here. Let's just say 10 hours. I'm not sure. We might want to make that a 20. And the Y min, can the concentration ever be lower than 0? No, it can't be lower than 0. And we don't know what these numbers are going to bring us. And so the concentration of a medication, I'm curious about what this is going to look like. So I'm going to choose 10 to start with, and let's see what happens there. So, all right. And so we could see we don't need to go up to 10, and we can go even up to just 2. It doesn't look like it goes up very high. And that's probably a concentration using a, so I guess that would be the percent concentration. So that wouldn't make any sense to even go above 1. So now that I've figured that part out, how many hours will the concentration be the highest? Well, we can see clearly we have a high point here on our graph, and so let's go ahead and calculate the maximum value there, marking the left-hand side as 1, and the right-hand side, let's say 4, and then let's guess 2 or something along those lines. So we can see that we have to understand here, we're being asked this question about after how many hours will the concentration be the highest? And it's important to make sure you understand what the x value means and what the y value means. So let's reiterate here. X is the t in our problem. T is the number of hours. And so when you look at the independent variable axis, that's the number of hours. So we can see that 2.16 means 2.16 hours after being administered. So this medication, a pregnant woman, it looks like, takes some medication, and then 2.16 hours after she takes it, the concentration will be the highest. So the concentration in the blood stream would be 0.759. So 0.759 is when the concentration is the highest concentration, and then that's after, again, that's after the 2.16 hours, about that many. Okay, and then it says a woman nursing a child must wait until the concentration is below 0.5 before she can feed him. So after taking the medication, how long must she wait before feeding her child? Well, that's where we go back to the y equals, and we want to see, well, where is that 0.5 mark? So we're going to put 0.5 there, and we're going to graph that as well. So we could see initially she could feed her child up until a certain point. So we want to second calculate the intersect, enter, and then we're going to put a 1 in there for our guess. So up until 0.7 hours after she takes the medication, she could still nurse. But it says, after taking the medication, how long must she wait before feeding her child? Well, we're looking really for the point of intersection over here, because if she starts feeding her child and she's still feeding her child 0.7 hours after taking the medication, then she'll have too much in her bloodstream, and that will be dangerous for the child. So we're going to wait until this point here, because as you can see, the concentration of the medication in the bloodstream starts waning, it starts getting lower, and then we want it to drop below that point right there. So we're going to second calculate intersect, so we can scroll down and hit intersect, and first curve enter, second curve enter, and then we're going to move the cursor over to this spot, and we can see clearly that after 4.465 hours she is allowed to start nursing her child. Okay, so that's the answer to that. After 4.465 hours, and we'll just leave it like that. We don't need to convert that to hours and minutes.